Good morning, everyone. Welcome to another English video lecture. Now, I apologize for the lighting. There's been constant blackouts where I live, and it's been really hard to record videos and upload them on time. That's the reason why my uploads have been late, is because I don't really have electricity to do anything. So I can't really upload, I can't really edit because I use a desktop. I don't have a laptop. I have a workstation, as you've already seen behind me. I've showed it to you in class, I think. So this is going to be the last video for this chapter. We're not afraid to die. I've covered everything. I've done basically everything that I could do. I've explained about as much as I could explain to you about naval science and all these nautical terms. I hope you guys have made your notes properly. I hope you guys have seen the clips and the videos that I've given to you as well. So let's just finish this today, and we can do the question and answers and everything else. I'll try to provide the question and answers soon. I know I haven't been providing PDFs to you guys. So what I want you to do is either Anjali or somebody else, who is willing to do it, make a list of all the PDFs that I have still to provide to you. Like all the videos that I haven't given you a PDF for, make a list of it and send it to me, so I can do it on my own, because like I said, it's really hard for me to keep track of two classes, like what PDFs I've provided, what I haven't, because it's really, really difficult to do it on my own. So a little help from anybody who can, just give me a list of the PDFs that I haven't provided to you, and I'll make sure to get them to you ASAP, which means as soon as possible. I know the reason I'm explaining is because I've been using ASAP while I'm texting you, some of you, and some of you don't get it. So ASAP means as soon as possible. I hope you guys know that. So I'll just finish this chapter quickly. This is not going to be a long video. I know the school wants me to make a 30-minute video, but there's just 2 pages left to explain, so I can't really make a 30-minute video on 2 pages. So I'll try to get this explanation done, then I'll try to tell you a little bit more about what I thought about the overall story and everything. And then once we are done, we can move on to the next chapter. So without further ado, let's just end this intro now and we'll move on to the main video.
So I'm on page 17 of your reader. So I'll be reading from this page. I think we've completed like the previous part. But if you want me to explain it again, just make a note of it and bring it up during the online lecture, and then we'll address it then. So for now, I'll just read this page and then I'll do the explanation as usual. Changes of course, drift, and current in an effort to calculate our position. The best I could determine was that we were somewhere in 150,000 kilometers of ocean, looking for a 65-kilometer wide island. While I was thinking, Sue, moving painfully, joined me. The left side of her head was now very swollen and her blackened eye narrowed to slits. She gave me a card she had made. On the front, she had drawn caricatures of Mary and me with the words, "Here are some funny people. Did they make you laugh? I laughed a lot as well." Inside was a message, "Oh, how I love you both." So this card is to say thank you and let's hope for the best. Somehow we had to make it. I checked and rechecked my calculations. We had lost our main compass and I was using a spare which had not been corrected for magnetic variation. I made an allowance for this and another estimate of the influence of the westerly currents which flow through this part of the Indian Ocean. About 2 p.m., I went on deck and asked Larry to steer a course of 185 degrees. If we were lucky, I told him with a conviction I did not feel. He could expect to see the island at about 5 p.m. Then, with a heavy heart, I went below, climbed on my bunk, and amazingly dozed off. When I woke, it was 6 p.m. and growing dark. I knew we must have missed the island with the sail we had left. We couldn't hope to beat back onto the westerly winds. At that moment, a tousled head appeared by my bunk. "Can I have a hug?" Jonathan asked. Sue was right behind him. "Why am I getting a hug now?" I asked. "Because you're the best daddy in the world and the best captain," my son replied. "Not today, John, I'm afraid." "Why, you must be," said Sue in a matter-of-fact voice. "You found the island." "What?" I shouted. "It's out there in front of us," they chorused, "as big as a battleship." I rushed on deck and gazed with relief at the stark outline of Isle Amsterdam. It was only a bleak piece of volcanic rock with little vegetation, the most beautiful island in the world. Alright, so now let's take a look at it from the beginning. So now he's talking about changes of course, drift, and current in an effort to calculate our position. Now, usually whenever you're in a sea, whenever you're in a ship, you're navigating using a lot of different equipment. Like earlier in the days, when you were sailing close to the coast, when ships were just built of tiny wooden pieces and everything else, you could just sail next to the coast, because if you lost sight of land, you lost where you were, right? Then people started learning how to navigate using the sun and the stars and the movement of the planets and the stars, and aligning themselves with constellations and all the other stuff. Then the sextant was invented, which allowed people to go on even longer voyages and chart their courses. People started making maps of ocean currents and wind currents and everything else. So I'll put a clip here if I can find after this piece, which explains how like sailors navigate in the ocean and everything else, so you guys can understand. But basically, like, it was a long journey for humanity to like understand how to move themselves across the oceans. That's why Vasco da Gama and people like James Cook, people like Columbus, people like Charles Darwin, even, these were all explorers who went, to different corners of the ocean. They explored everything, and that was like the great age of discovery. It was called, where ships were trying to reach different places. Most of the reason why Europeans left were because of spices. I think like spice trade was very important. Other trade was very important. They were looking for slaves. They're looking for new land. They were looking for anything else. If you haven't seen, there's a show on the History Channel called Vikings, which you should watch. Like the first two seasons are worth watching. After that, it just gets boring. So you can just watch the first two seasons of Vikings, and that will tell you a lot about how Vikings were the first original naval navigators. They were the first ones to figure out how to use the sun to sail and how to set courses and how to reach. Like they were the first ones to reach America long before the British landed there, long before Christopher Columbus landed there. Like Vikings had already reached American coast, sailing all the way from Norway into like the Atlantic Ocean and then crossing it with their long boats, with their Viking boats. So this is why like it's very important for you to understand like the history of naval navigation and everything else, because it allowed human beings to reach places where they never could have. It allowed people to travel around the world and show that the world was indeed round, that you can leave from one place and come back to it, like if you sailed correctly. So they're looking for like a 65-kilometer wide island. Like I've shown you a picture of Isle Amsterdam. You can look it up on Google. You can find where Isle Amsterdam is located. But it's a 65-kilometer wide island, and the ocean is 150,000 kilometers wide. So you are trying to basically find a needle in a haystack. While I was thinking, Sue, moving painfully, joined me. The left side of her head was now very swollen. Her blackened eyes narrowed to slits. She gave me a card she had made. On the front, she had drawn caricatures of Mary and me with the words, "Here are some funny people. Did they make you laugh?" I laughed a lot as well. So now this shows you like the kid's resilience, right? Like a kid has got his head bashed in. She's got her eyes swollen. She might have a concussion. She probably might have like a minor skull fracture even. But she's still making a card. She's still trying to make her parents laugh, and she's trying to tell them that she loves loves them both, and she's trying to be supportive, and she's trying to show, her appreciation for her parents, which is kind of strange. No 7-year-old I know would be able to do it after, as even with her head banged up. I'm pretty sure even I wouldn't be able to do it if my head was like swollen and my eyes were narrowed to slits. I probably wouldn't have been able to make a card for anybody. So hats out to this kid, tough as hell, tough as nails. Maybe she goes on to become Wonder Woman in a future story. I don't know. So let's move on. I checked and rechecked my calculations. We had lost our main compass, and I was using a spare which had not been corrected for magnetic variation. Now, this is very important. People think that compasses are usually used to find directions, or they somehow point in the direction that you want to go. No, compass points towards the magnetic north pole, so that allows you to orient yourself in the direction that you're going. So it allows you to find out where east is or west is or where south is, so you can orient yourself in that direction, and it will always point towards the magnetic north or true north. I'm not really sure. Like I said, I'm not a navigator. I don't really know much about navigational sciences and how does like magnetic variations affect compasses. I'm pretty sure if there's a science student watching this video from my class, or you can ask your physics teacher how it works, or you can ask your geography teacher how it works. I'll try to put a clip here like that educates you, and I'll try to watch it so I learn as well, so we can all learn together, because I don't really know how this works. So I'll try to watch this clip. I'll try to learn, and I'll try to put it for you guys as well. So I made an allowance for this. Basically means he's making a judgment. He's leaving a margin of error. So for example, like if I have to travel like 30 degrees north, let's say, but my compass is not corrected for magnetic variation, so I'll have to like turn my ship 60 degrees to allow for the 30-degree deviation. But I mean, that's what I believe. That's what I think is going to happen. So another estimate of the influence of the westerly currents which flow through this part of the Indian Ocean. Now there is like a map which shows you like all the ocean currents and everything. I'll try to find an animated version of it to add to this video, which will add some more depth to your information. About 2 p.m., I went on deck and asked Larry to steer a course of 185 degrees. Now I said like you can adjust the degrees that you're turning based on like your compass or whatever information you might have. If he were lucky, I told him with the conviction I did not feel, he could expect to see the island at about 5 p.m. Now he's tired, his ship is battered up, he's not sure if he's making the right reads, he's not sure if he's giving the right directions to anybody. So he doesn't have a conviction, or he doesn't have faith in his decision to, turn 185 degrees and follow this course. So he told him like he could expect to see the island at about 5 a.m., right? Then, with a heavy heart, I went below, climbed on my bunk, and amazingly dozed off. Now, this dude has been trying to keep his family alive, trying to keep his ship safe, trying to keep everybody safe ever since the storm started. So he deserves a bit rest or something, and he goes and he dozes off. So when he woke up, it was 6 p.m. So he realized, like, if it was 6 p.m., then like he probably might have missed the island. So he doesn't really think that his conclusions were right, that his whatever he thinks was right. So he is like, pretty desperate and pretty dark. So at that moment, a tousled head appeared by my bunk, and I have a hug. So now his kids are here. They're asking for him for a hug. Now this is like just a conversation about everything. They found like the island. It was only a bleak piece of volcanic rock with little vegetation, the most beautiful island in the world. So now, like I said, it's such a huge relief for them to be out of the storm, to be out of the ocean, to finally land their ship somewhere. So that even if it doesn't matter if this was just like, a 65-kilometer piece of volcanic rock in the middle of the Indian Ocean, to them it was like the most beautiful island in the world, because after all the struggle they've been through, they finally made it. They're finally here. All right, so this is like this page has been explained. So I'll put forth clips now after this break, and then we'll just like end the chapter. And there's some question and answers I'll address, and then the rest we can do on the online lecture.
Before we can get far into navigating, we need to take a look at how we, as navigators, define an object's position on Earth. We'll start by taking a close look at the globe and notice how it's laid out on a grid system. Anything on Earth can have its position determined by this grid system. You can see the lines that make up these grids running across the globe from side to side and from top to bottom. The lines that run across the globe from side to side are called lines of latitude and are numbered in degrees starting from 0, also known as the equator, and ending at 90 degrees on both the north and south poles. You'll also notice that these lines are always running parallel to each other. For this reason, they're also referred to as parallels, as in Iraq's no-fly zone below the 36th parallel. You can also look at them as rungs of a ladder, which may help you remember the term latitude. It equals like a ladder. As you count upward from the equator, you are counting north latitude. Here's 10 degrees north latitude, 20 degrees north latitude, and so on. So guess what you're counting as you go south? That's right, you count south latitude. Now the lines running up and down the globe look long and are called lines of longitude, or sometimes meridians. And instead of running parallel to each other, they converge and meet at both the north and south poles. They start at 0 degrees at Greenwich, England, also known as the prime meridian, and run east or west from there until they get to the other side of the world at 180 degrees, also known as the international dateline. As you go west from the prime meridian, you count west longitude. Here's 20 degrees west, 40 degrees west, and so on. So guess what we count as we go east of the prime meridian? You got it, east longitude. Now let's take a look over here at the Atlantic Ocean. We see we have a line of latitude running through it of 30 degrees north. We could say that we're somewhere on that 30-degree line of north latitude, but we need to be more precise than that. That line runs all the way around the world, and it would make a pretty big search area if we just told the Coast Guard that we were at 30 degrees north latitude. So let's find an intersecting line. Here's one running through our 30-degree line, the 60-degree line of west longitude. If we were at 30 degrees north latitude and 60 degrees west longitude, we would know that we were at this point right here, just southwest of Bermuda. Now, it doesn't always work quite so neatly, where your position will intersect right at whole degrees. That's why there are smaller lines between the degrees called minutes, and there are 60 lines of minutes between each degree. Now let's take a look at this body of water off the coast of Massachusetts. Nantucket Sound has a line of latitude running through it of 41 degrees, 30 minutes north, and a line of longitude of 70 degrees, 20 minutes west. That puts us just north of the center of Nantucket Sound. Again, it just doesn't work out that cleanly, where your position is right at the intersection of an even number of minutes of degrees. So that's why between each of these minutes are smaller lines called seconds, and there are 60 seconds between each minute. The problem with working with seconds is that our charts would look awfully busy with that many lines on it. So they decided to make it easier on us all and broke the minutes of degrees down into 10 lines called tenths of minutes. So now, by using degrees, minutes, and tenths of minutes, we can tell anyone in the world exactly where we are in the world. Okay, so now that we have latitude and longitude down, let's take a closer look at our nautical chart and see what's what. What about all these numbers all over the place? Those are depths. Are they feet, meters, yards, fathoms? I don't know. We have to look. See right over here? In big letters, it tells us that the soundings are in feet. If this were an ocean chart with really deep water, the numbers would be too big to print all over the place, and you would use fathoms. And 1 fathom is 6 feet. And by the way, just because the chart says that the depth right here is 3 feet, doesn't mean that you can go stand there in 3 feet of water at any time. Remember, the tide comes in, the tide goes out, so it varies. And all of these measurements, or soundings if you will, are taken at average low water. So if you get stuck at high tide, you're going to be in a world of hurt at low tide. How much further will you be stuck at low tide? Well, the range of the tide can be found in an informational box on your chart right up here. Look at the mean high water measurement and you'll see 3.2 feet as we enter Hyannisport. Notice that if you look closely, you can also get information on the quality of the bottom. This is very useful when anchoring. A soft bottom may feel good, but it won't hold your anchor very well, and rocks may decide to keep your anchor permanently. When dealing with navigation, it's important to understand some definitions for what we'll be dealing with. We'll start with directions. Directions are given either in true or magnetic degrees. There are 2 choices because there are 2 North Poles. There's the true North Pole, where Santa Claus lives, and the magnetic North Pole, which is actually closer to Arctic Canada. The magnetic North Pole's position is dictated by the magnetic field of the Earth, and because this magnetic field changes slightly every year, the location of the magnetic North Pole changes slightly every year as well, nearly 40 kilometers to the northwest per year. The difference between true and magnetic north is called variation. Notice the compass rose on your chart will give you your degrees in directions true on the outer circle and degrees magnetic on the inner circle, and in the center, the actual variation or difference between the two for where you are and the amount it changes every year. Now, it's important to understand that this angle of variation, or difference between true and magnetic north, changes as you change your location. To illustrate this, if you're here in the east coast of the U.S., the amount of variation is about 15 degrees 45 minutes westerly. But go way over to the other side of the world, and you see how the 2 positions are more in line with each other? Now the variation is almost 0. That's why there will be a different amount of variation for different locations. Your compass always knows where magnetic north is. It's when you're figuring a course from your chart that your compass will understand that warrants having to deal with variation. And we'll get back into this later when we start plotting. Directions are given as an angle from north, which is the 0 position, and continue from there all the way around the circle to 360 degrees, which will be north again. It's not appropriate to call north 0 degrees, so we always say 360 degrees when discussing north. Directions are always given in a 3-digit format. East is not 90 degrees, it's 090. West is 270. For every direction, there's a reciprocal, which is 180 degrees opposite. Half of 360 is 180, so all opposite courses are 180 degrees opposite. So, the reciprocal of 090 is an additional 180 degrees, or 270 degrees. And the reciprocal of 210 degrees is 180 degrees less, or 030 degrees. How do you know whether to add or subtract 180? Well, you do whichever gives you an answer of 360 or less. Or an easier method, and I really hate math, so I always go for easier, is to just look at the opposite side of your compass or the compass rose. When labeling your courses on a chart, always, always, always add T for true or M for magnetic after the 3 digits, as in 185M for 185 degrees magnetic. For all our work, we'll be using magnetic as it correlates to the compass on our boat, so let's always use the inner circle. Well, there you have it. Hopefully this course will have given you a better understanding of basic navigation so that you'll always be in charge of where your boat is and when, rather than having the boat be in charge of you. If you enjoyed this segment on basic navigation, then be sure to try out some of our other programs like Requirements for Recreational Boaters, Aids to Navigation, basic rules of the road, or how to handle emergencies. And of course, all of these courses and so much more can be found all together in one place, Smart Boating, our most popular course ever. It's been a pleasure having you with us. I'm Captain Steve. Thanks for joining us, and we'll see you out on the water.
An ocean current represents ocean water in continuous movement, generated by wind and differences in water density. Ocean currents are driven by winds blowing predominantly from a single general direction, called prevailing winds. These winds include the trade winds, the westerlies, and the polar easterlies. The direction of these winds is determined by the force caused by the Earth's rotation, the Coriolis Effect. In a hypothetical situation in which the Earth has a single ocean and a single continent, the trade winds in the tropics would blow the upper few hundred meters of the water from the east to the west. The current would split upon hitting the continent. A part of it would flow back along the equator, while the rest would change direction northeast and southeast to the westerlies. If these branches reached the continent again, they would split once more. Some of the currents would travel back towards the equator, while others would change direction and flow, deflected towards the west, due to the effect of the polar easterlies. For this reason, two interconnected gyres flowing in the opposite direction would form in both the northern and the southern hemispheres. The irregular shape and position of the continents, however, modify ocean current patterns. For example, in the southern hemisphere, the second gyre can travel around the Earth in the zone of the westerlies without coming in contact with a single continent. Currents that move from the equator toward the geographical poles and carry warmer water than the surrounding waters are called warm ocean currents. Currents that travel from the geographical poles toward the equator and carry water that is colder than the surrounding waters are called cold ocean currents. Water currents do not only move horizontally, but vertically as well. The animation shows the surface and deep ocean currents of an idealized ocean. Vertical motion is caused by differences in temperature and salinity. Warm water near the equator has a higher salinity and density due to evaporation. Moving northward, the water cools down, while its salinity level remains constant. Since its density is higher than that of the lower water mass, the surface water sinks into the ocean basin and flows back towards the equator, forming a cold, deep ocean current. Here, the cold body of water rises, thereby closing the cycle. In reality, the surface and deep ocean currents in the oceans form a global system called the global conveyor belt. Deep waters flow the most intensely in the North Atlantic deep water. The North Atlantic deep water can be found in the eastern part of the North Atlantic Ocean, near the end of the Gulf Stream, where it sinks and continues to flow southward as cold water current. It travels almost around the entire planet, rising only at the Indian Ocean and the Pacific Ocean to continue as warm water current. The time it takes for a water molecule to travel around the planet is up to 1,000 years. Ocean currents have a significant impact on the Earth's climate. When warm water currents reach a coast, that area will have a higher annual mean temperature. The mean temperature near cold water currents is lower than the average temperature of that particular latitude. For example, the annual mean temperature of Western Europe would be 5 to 10 degrees Celsius lower without the Gulf Stream.
So on the final page, we have just one paragraph, which means we have a happy ending. So we anchored offshore for the night. The next morning, all 28 inhabitants of the island cheered as they helped us ashore with land under my feet. Again, my thoughts were full of Larry and Herbie. Cheerful and optimistic under the direst stress, and of Mary, who stayed at the wheel for all those crucial hours. Most of all, I thought of a 7-year-old girl who did not want us to worry about a head injury, which subsequently took 6 minor operations to remove a recurring blood clot between skin and skull, and a 6-year-old boy who was not afraid to die. Now, look at this. This is what I mean. Like, I was telling you guys since like this video began, since the chapter began, like that head injuries are not a joke. So, do you realize that? Like, there's a 7-year-old girl who had like 6 minor operations. Like, no, I don't care how minor an operation is. They're still cutting into your skull and to remove like a recurring blood clot. Do you realize that that's so lucky? Like, if that girl is so lucky that blood clots is happening like between the skull and the skin, not like inside the skull and the brain. Otherwise, she would be like a vegetable. She would be paralyzed. She might never be able to walk again or talk again. She might have a stroke. There's a million things that can happen. Like, head injuries are not a joke. All right, I'm like very concerned about this because like I've seen like a lot of people, a lot of my friends and everybody else, just joke. It's because I used to do like something called MMA. I don't know if you guys know UFC MMA. I used to be like heavily into MMA. I used to do Brazilian Jiu-Jitsu. I used to do kickboxing when I was younger. Then I injured my knee and everything else. So ever since then I can just only do grappling now. So I don't do striking anymore. But back then we were like idiots. We would like spar on concrete, like literally concrete floors, and we would try to knock each other out. We would try to take each other down, slamming each other's head on the floor. And then like somebody would wake up and have a nosebleed the next day, and like somebody can't talk, and like we had so many concussions when we were younger. That's why my memory is so bad now. Like I can't remember anything, and like my parents didn't take it seriously. They were like, oh no, it's just a head injury, like just walk it off, be a man. So that's the reason why I'm so concerned about head injuries, is because they are pretty freaking serious. Like, people don't pay enough attention to head injuries. I know this has turned into a rant about head injuries out of nowhere, but please be careful. Like, whenever you're playing or whenever you're doing something, whenever somebody is injured to the head, whenever somebody takes like a blow to the head, try not to move them too much. Try not to, put pressure on the area or something. Always make sure to go check their reflexes with their eyes and ask them like if they have a headache or if they feel something different. Because concussions are not a joke, people. Like, it's really not a joke. Like, I can feel it right now. Like, I can feel the brain damage that I've inflicted upon myself at my age right now. I'm going to be 30 soon, and I can already feel like, headaches, bad memory. I don't remember anything. Like, my short-term memory is absolutely gone. I just have to rely on making copious amounts of notes. So that's the reason why, like, 7-year-old head injury, minor operation, then a 6-year-old boy who's not afraid to die. Yeah, this is a happy ending, but once again, I will maintain my position that these parents were freaking idiots taking a 6 and a 7-year-old on a boat in the Indian Ocean where it's so dangerous and everything else. Like, I've been researching so so much, and like this is the only story I've ever found like where people took like their kids with them on like such a dangerous trip. Like, this is just child endangerment, and if this was in the 70s, this would be considered child abuse. I'm pretty sure this was child abuse. So anyways, as long as we have a happy ending, I'm fine. But like, that poor girl had a serious head injury, and I hope she's a grown old lady now. Like, since like she was 6 years old, 7 years old in 76, so she's pretty old now. So she might be in her late 40s, I guess. I hope she doesn't have any recurring complications, and I hope she doesn't have like a stroke or something. Anyway, so this is over. So let's just take a look at the next part, understanding the text and talking about the text. All right. So list the steps taken by the captain to protect the ship when rough weather began, to check the flooding of the water in the ship. Describe the mental condition of the voyagers on 4th and 5th January. Describe the shifts in the narration of the events as indicated in the 3 sections of the text. Give a subtitle to each section. Now, all these questions, like you see in this page, like all these 7 questions, write them in your rough notebook. All right, have your answers ready in your rough notebook, because we'll address them in the online lecture. All right, we'll go through them on the online lecture, and I'll try to give you answers and everything else. And the rest of you guys, like, who are here, Anjali and all the other ones. Anjali, I'm referring to you because you are the one who talks the most in class. You're the one who like says, sir, we have to do this, or we have to do that. So like, take this responsibility, do this. Yeah, I'll make fun of you for doing it because you're a nerd, but don't take it personally. I'm just making fun of you because like, you guys are my students and I want to like have fun with you guys. So don't take anything I say personally, because I say even more horrific shit to the people I love, and you guys are just my students, and like, you guys don't even know me for that long, and I make horrific jokes to people who have been my friends for 15, 20 years. So don't take anything I say personally. It's just jokes, people. All right, so just have these questions ready for your rough notebooks, and we'll address them in our online lecture. So this is the end of this chapter. This chapter is done now. We'll be moving on, and we'll discuss like what chapter to do next in our online class. So I hope you guys enjoyed this explanation. I hope you guys watch all videos. I hope you guys do these questions in your rough notebook, and I'll see you in the online lecture.